Hey, this is Joe at Gray Bench Electronics. Welcome back to the pedal teardown series where I take apart new and interesting pedals and show you what's going on inside. Today we have the Audio Kitchen fake plastic trees. Okay, fake plastic trees from Audio Kitchen in the UK. This is conceptually a remake of their Big Trees pedal format amplifier, but using JFETs for the gain stages. At least according to the documentation, that was the starting place of sort of emulating an EL84 amp. But they did a bunch of work and testing and blah, blah, blah simulation to arrive at the pedal here. The Enclosure is a very tall, it appears to be the sort of the face of a 1590B, but quite tall. And that is because there are two transformers in this pedal. Controls wise, we have a volume knob, a root knob, which is the bass control, a branch knob, which is treble, and gain for gain. On the top here, we have input and output jacks, PCB mounted DC input jack. Pedal needs 100 milliamps from the supply, which is more than a standard pedal, but not a crazy amount. Still 9 volts DC, center negative. And on the back here, Audio Kitchen, fake plastic tree, serial number 160. Caution, risk of electric shock, do not open. So let's ignore that warning and open up the pedal. All right, so here's the PCB for the Audio Kitchen fake plastic trees. As you can see, we have two interesting components here. One obviously is a transformer with the windings exposed. The other component here is, I believe, also a transformer. There are no visible outer markings, and I suppose that any indication of what it is underneath this sticker here. I'm not going to be removing that because, as you may know, I sell all the pedals that I get for the Teardown series here, and I wanted to be original for the next owner of the pedal. There are some components here that we can identify. We have a big 220 microfarad filter cap there, most likely. It appears a lot of these components here are going to be power supply related. This little surface mount chip is a Analog Devices ADP 5070, I believe, is what it says. The writing's really small. But it's a 20-pin voltage regulator inverter. It appears to be able to do positive and negative voltage supplies, and you can have a lot of control over the exact voltages. The documentation says that this pedal has a 40 volt of headroom, so potentially plus 20, minus 20, something like that. The foot switch here is interesting. It uses a blue 3-pole double throw foot switch, but only one side of the lug. And that's because although it is one of the standard latching foot switches, it is in fact relay switching there with that little relay, which part number says IM05 or Q5. Appears to be double pole, double throw, so switching the input and output of the pedal. So it will be true bypass with relay switching, but usually you would expect to see a non-latching switch, just a momentary switch, and single pole, single throw, because you get the benefit of a more robust switch, and it also just generally feels better to not have that click. Here you're kind of losing that because you're using one side of switch of a 3-bank switch, and these switches don't last as long. So, you know, it's one of those things. There might just be an economy of scale thing where you can just order a bunch of these for all kinds of different pedal projects, and yeah, you can make it work for this pedal. But it would have been nice if you're going relay switching to use that non-clicking foot switch. Input and output jacks are just mono jacks, no ring connection there. PCB mounted DC jack as we saw before. There appears to be not really any audio signal stuff happening on this side of the board, but of course we are double-sided. So let's flip over to the business end. So first off, Got a little piece of protective card here to protect any of the components underneath from shorting out to the top of the potentiometers. The potentiometer values, as you can see there, are all logarithmic or audio 1 megs. On this side, we have some components worth calling out. As I said, it's a JFET preamp or overdrive pedal. And we do have a couple little JFETs, one there. There's a few more hiding underneath. I think it's a total of 4. Let me count again. Yeah, so it appears to be a total of 4 JFETs. We have one here, one hiding under the volume potentiometer, one right here between the treble and gain controls, and then another one underneath the treble control. They do have little paint markings on them, which implies some sort of a selection or auditing process. The rest of the components here are just pretty standard surface mount resistors and capacitors. We do have a little 8-pin dip package there, which has extremely faint lettering that I can't actually read. If I had to guess, I would assume this is a microcontroller for the relay, but it's possible that the relay is not being used microcontroller based. It might be a different scheme for doing the relay switching, which is possible. The reason I think that is because it's on the wrong side. You would expect it to be somewhere over here if it is a microcontroller for the relay switching. PCB design is slightly annoying in that if you had to go and replace any of the JFETs, especially the ones hiding underneath the potentiometers, you would have to remove the pots to get to those. That's sort of annoying. There's plenty of board real estate here that it could have been pulled out from underneath there. JFETs are fairly robust now, so I don't know how often you would be actually replacing JFETs, but there's space on the board. It's not as if there wasn't places to put it. Perhaps they're trying to keep the components away from the transformers for noise reduction purposes, something like that. Not sure. The board design otherwise is pretty good. We've got different size traces, taking into account current draw, little red 3mm LED for indication. Flip back over the other side. So the markings on this transformer, and I looked these up, by the way, I couldn't find any information on them. This one's marked TT5918. WO.52824, and of course the secondary transformer here does not have any markings, or if they do, they're underneath the sticker. So that is the PCB for the fake plastic trees from Audio Kitchen. Let's go ahead and put the pedal back together. All right, that concludes the teardown of the Audio Kitchen fake plastic trees. If you have any questions or recommendations for a pedal you want to see on a future teardown episode, let me know in the comments. If you enjoyed the video, I'd appreciate you hitting the like button and subscribing, and hit the notification bell if you want to know when I make a new video. I am Joe from Gray Bench Electronics. Thank you for watching.